Hi, and welcome to Allen High School's discussion of chemistry at the APIB HL1 level. We've been working in stoichiometry, and we're moving into questions that involve percent composition. Now, there are a variety of ways to do this. I know this writing's a little small, but kiddos, you have those notes in front of you. Sorry about that, the rest of you. Hopefully you can see that. All right, I love emeralds. Emeralds are made of, include beryl. And this is a chemical formula of beryl with 3 berylliums, aluminum, silicon, and oxide. So silicates or silicon oxides are often the substrates for a lot of gemstones. So I thought this was a pretty interesting question. And we are going to find, when we talk about the atom, that when we have substances, when we have metals, especially like chromium, that have incomplete D sublevels, they're colored. Okay? Now, what we want to look at, they have trace amounts of the chromium that gives it the color. Beryllium, aluminum, silicon, those are all colorless. All right, now we have 125 grams of beryl, and the question is, how many grams of beryllium are present? Well, there's 3 different approaches to this, and they're very similar. In fact, you'll see numerically they're nearly identical in this setup. But the last one that I like to focus on is a little bit more streamlined. So let me walk you through here. Here's my mass of beryllium. I can go mass to moles through the heart of chemistry. Moles to moles is always through the heart of chemistry. And then based on that little subscript, I know that there are 3 moles of beryllium for every 1 mole of beryl. And now I have moles of beryllium. So this is like going moles to moles within. When you do moles to moles within, you use subscripts. Or when you do moles to ions within, you use subscripts. So that's what that step is. And now we can go moles back to mass using the molar mass. And you would get, assuming I did my algebra correctly, every once in a while, especially if I'm using my phone, I mess up on that silly algebra. Okay? So that's one way. Now the other way is to use percent composition. Percent composition, what we're doing is we're following that law of constant composition that says the percent of each element in a pure substance is in a pure substance, not mixtures, mind you, but in a pure substance, that the percents are going to be constant. So what we're really doing right here is in this step, we're calculating the percent composition based on 1 mole. Since this is an intensive property, we can assume whatever we want. But if we assume 1 mole, then the mass of the part, there's 3 berylliums times 9.01, divided by the whole, that's 1 mole of the beryl. And then times 100, and we get 5.03%. So it doesn't matter how much of that beryl we have, 5.03% of it is beryllium. And so now all we have to do is take our given amount, multiply it by the percent that's beryllium, and we get 6.29 grams. So you see that both of those are a little bit long, and there is a way to very quickly combine and simplify those steps. So I call that using the mass to mass ratio. In the mass to mass ratio, what we're going to do is we're going to take just the front portion of this as a mass to mass ratio. So we have 125 grams of my beryl. All right, BERYL. Okay, that's the formula up there. Now, I better be more careful. You guys, let me put down the formula for you so you see this much more clearly. So we have the 3 berylliums, aluminums, and the SiO3, 6. Now, I want to get rid of grams of the beryl. I'm not going to write that again. You see that. And I want grams of beryllium. Okay. Well, that ratio tells me I have 3 times 9.01 grams. So that's the mass that beryllium contributes for the whole 537.50 grams of the barrel. Okay, so it's a mass to mass ratio. So all we really did is took that portion of it, and so we're not like calculating a percent and then going backwards a percent. And you should get your 6.29 grams of beryllium. Now, I don't care which of these methods you use. So whatever one works best for your mind, that's what you need to do. But what you must always do is show me your work. So until we are in class and you are beautifully doing that, this is signing off.